In this chapter, we will learn some properties of dilute solutions. So, what is a solution? A solution is a homogeneous mixture of two or more substances on molecular level, the composition of which can be varied within certain limits. The substances with which the solution is made are called components of the solution. A solution with two components is called binary solution. And the two components of a binary solution are called the solute and the solvent. One of them is called the solute and other one is called the solvent. So if we have a solution of sodium chloride in water, you take water in a container and to that you add some sodium chloride so that you get a solution. Now sodium chloride is in the solid state and water is in the liquid state. And when the solution is formed, the solution is also in the liquid state. So the component having the same physical state as the solution is called the solvent. So here water is having the same physical state as the solution. So here water is the solvent and the other component is the solute. So NaCl is the solute. But in case both the components are in the same physical state, for example, mixing water and ethanol, you get a solution and all the three are in the same physical state. So in such case, the component which is lesser in amount is called the solute and the component which is more in amount is called the solvent. Concentration is the expression of how much of solute is present in 1 unit of solvent or solution. That is how much of solute is dissolved in how much of solvent. And here we are concerned with dilute solutions. So a solution containing very low concentration of solute is called dilute solution. There are different ways of expressing concentrations. Ways of expressing concentration. The first one is molarity. M. It is the number of moles of solute present per liter of the solution. So M is equal to number of moles of solute divided by volume of solution in liters. If volume is expressed in terms of milliliters, we can write this as number of moles of solute divided by volume of solution in milliliters into 10 raised to minus 3. That is, if we are given 2 milliliters, it has to be converted to liters by multiplying with 10 raised to minus 3. This is equal to number of moles of solute divided by volume of solution in milliliters into 1000. Now we can get one more expression. We know molarity is equal to number of moles of solute by volume of solution in liters. And number of moles is equal to mass of the solute taken divided by molar mass. So instead of number of moles, we can write M is equal to mass divided by molar mass divided by volume of solution in liters. We can just rearrange this. This is equal to mass divided by volume of solution in liters divided by molar mass. Now mass by volume of solution in liters is nothing but mass per liter. divided by molar mass. So molarity is also equal to mass per liter by molar mass. Second one is molality. Small m. It is the number of moles of solute present per kilogram of solvent. So small m is equal to number of moles of solute divided by mass of solvent in kg. If the mass of solvent is expressed in terms of grams, we can write this as number of moles of solute divided by mass of solvent in grams into 10 raised to minus 3. This is equal to number of moles of solute divided by mass of solvent in gram into 1000. Now just as we have written for molarity, we can write the expression for molality as number of moles of solute divided by mass of solvent in kg. And number of moles is mass by molar mass, mass of the solute divided by molar mass of the solute divided by mass of solvent in kg. So we can rearrange this. So this is equal to mass of solute divided by mass of solvent in kg divided by molar mass. Mass of solute by mass of solvent in kg is mass of solute per kilogram of the solvent or mass of solute per 1000 gram of solvent. So molality is mass of solute per 1000 gram of solvent divided by molar mass. So molality can also be calculated by this expression. Now next one is mole fraction. It is the number of moles of a component per mole of the solution. So we can write this as mole fraction is equal to number of moles of a component divided by total number of moles of all components. For example, consider a binary solution and you have two components A and B. Number of moles of A be Na and number of moles of B be Nb. Total number of moles N is equal to Na plus Nb. So from this we can write expression for mole fraction of component A. Xa is equal to number of moles of A divided by total number of moles. And mole fraction of component B, Xb is equal to Nb divided by Na plus Nb. If Xa and Xb are added, we get Na divided by Na plus Nb plus Nb divided by Na plus Nb. This is equal to 1. So sum of mole fractions of all the components in a solution is 1. Now fourth one is normality. N. It is the number of equivalents of a component per liter of the solution. So N is equal to number of gram equivalents of the solute divided by volume of solution in liters. Number of gram equivalents is equal to mass of solute divided by its equivalent mass. So we can write in the expression for normality N is equal to number of equivalents is equal to mass divided by equivalent mass divided by volume of solution in liters. We can rearrange this is equal to mass divided by volume of solution in liters divided by equivalent mass. So mass by volume of solution liters is nothing but mass per liter. So we can write normality is equal to mass per liter divided by equivalent mass. This expression can also be used for calculation of normality. You must be familiar with this expression when you have done volumetric analysis. Molality and mole fraction depend on mass and not on volume. Hence, these are independent of temperature. Now, unit of these terms, the first term was molarity, which is number of moles of solute by volume of solution in liters. So, its unit is, in the numerator you have moles and denominator liter. So, it is moles per liter. Next is molality. This is number of moles of solute by mass of solvent in kg. So, this is numerator is number of moles is mole and denominator is kg. So, it is mole per kg. Mole fraction. It is number of moles of a component divided by total number of moles of all components. So, this is mole divided by mole. So, it has no unit. So, it is because it is just a fraction. And normality, number of gram equivalents of solute by volume of solution in liters. So, this is equivalence divided by volume in liter. So, this is equivalence per liter. Now, moles per liter is represented as capital M and moles per kg is represented as small m and equivalence per liter is represented as capital N. We will see some problems. What is the molality of a solution containing 3 gram of urea of molar mass 60 in 200 gram water? Molality is equal to mass of solute in 1000 gram of solvent divided by molar mass. Here we will first find out the numerator part. Molar mass is equal to 60 grams per mole. Now 200 grams of water contain 3 grams of urea. Therefore 1 kg of water, which is 1000 grams, contain 3 divided by 200 into 1000 grams of urea. This is equal to 15 grams of urea present per kg. So molality is equal to 15 grams per kg divided by 60 grams per mole, which is equal to 0.25 moles per kg or 0.25 m. Find molality and normality of 15% solution of sulfuric acid by mass. Density of sulfuric acid solution is 1.1 grams per ml. So, we'll first find molarity. Molarity is equal to mass per liter divided by molar mass. Now, molar mass is equal to 98 grams per mole. Now we have to find the numerator part, which is mass per liter. Now for that, its percentage is given as 15%. Percentage of sulfuric acid is equal to 15%. It means that if you take 100 grams of the solution, it contains 15 gram of sulfuric acid. So mass of sulfuric acid in 100 gram of solution is equal to 15 grams. Now what is the volume of this 100 gram of solution? That we can find out because density of the solution is given. Density is mass by volume. So volume is mass by density. So we have to find the volume of the 100 gram of solution. So volume of solution is equal to mass by density. And this is equal to mass is 100 grams and density is 1.1 grams per ml. So this is equal to 90.9 ml. So if you take 90.9 ml of the solution, it will contain 15 grams of sulfuric acid. So instead of writing 100 gram of solution, we can write 90.9 ml of solution. So mass of sulfuric acid in 90.9 ml is equal to 15 grams. And we want the mass of sulfuric acid in 1 liter. So mass of H2SO4 in 1 liter or 1000 ml solution is equal to 15 divided by 90.9 into 1000, which is equal to 165 grams per liter. So molarity is equal to mass per liter divided by molar mass. This is equal to 165 grams per liter divided by 98 grams per mole. This is equal to 1.683 moles per liter or 1.683 capital M. Now molality is equal to mass per kg or 1000 gram of solvent divided by molar mass. Now remember, this is solvent and not the solution. So again, the solution is 15%. It means mass of sulfuric acid in 100 gram of solution is 15 grams. And mass of solute plus mass of solvent is equal to mass of solution. Now we want mass of solvent. So mass of solvent is equal to mass of solution minus mass of solute. This is equal to 100 minus 15. And this is 85 grams. So mass of sulfuric acid in 85 grams of solvent is equal to 15 grams. We want mass per kg of the solvent. So mass of sulfuric acid in 1 kg of the solvent or 1000 grams of the solvent, which is equal to 15 divided by 85 into 1000, which is equal to 176.47 grams per kg. Therefore, molality is equal to mass per kg, mass per 1000 gram of solvent divided by molar mass, which is equal to 176.47 grams per kg divided by 98 grams per mole, which is equal to 1.8 mole per kg, which is equal to 1.8 m. Now normality is equal to mass per liter divided by equivalent mass. And equivalent mass of sulfuric acid is 49 grams per equivalent. And mass per liter we have already calculated. So normality is equal to 165 grams per liter divided by 49 grams per equivalent, which is equal to 3.367 equivalents per liter or 3.367 capital N. A solution contains 25% water, 25% ethanol and 50% acetic acid by mass. Calculate the mole fraction of each component. Let the total mass be 100 grams. So mass of water will be 25 grams. Mass of ethanol will be 25 grams. Mass of acetic acid will be 50 grams. Now we have to calculate number of moles of each components. Number of moles of water is equal to mass by molar mass. Mass is 25 grams and molar mass is 18 grams per mole. Is equal to 1.388 moles. Number of moles of ethanol is equal to mass is 25 grams and molar mass is 46 grams per mole. So this is equal to 0.543 mole. Number of moles of acetic acid is equal to mass is 50 gram divided by molar mass is 60 grams per mole is equal to 0.833 mole. Now total number of moles is equal to 1.388 plus 0.543 plus 0.833 is equal to 2.764 moles. So mole fraction of water is equal to number of moles of water, that is 1.388 divided by total number of moles, 2.746 moles. So this is equal to 0.502. Mole fraction of ethanol is equal to number of moles of ethanol is 0.543 divided by total number of moles is 2.746 moles. This is equal to 0.196. Now we can similarly find the mole fraction of acetic acid also, but we know the sum of mole fractions is 1. That is mole fraction of water plus mole fraction of ethanol plus mole fraction of acetic acid is equal to 1. So mole fraction of acetic acid can be easily calculated as 1 minus mole fraction of water plus mole fraction of ethanol, which is equal to 1 minus, which is equal to 0.302. So here are two homework problems.